Hey guys, good morning. Excuse me. Good morning. Hey, so because of the way things are with this snow day and all that, we're just going to go ahead and give you another day on the SciExcel because we all need to work anyway. Um, as usual, my video card is overwhelmed, so let me just get rid of my webcam there, as I don't think it's going to be doing us much good. All right, so I was helping someone out with R10, and I realized that using trigonometry is not going to give us the answers that IXL wants. But, luckily we did learn how to do this. This is a special right triangle. And we've done a lot of special right triangles before. And, granted, it's been a while. But I figured I'd review a couple of them just so you might have a little bit of an easier time, working through these. Okay? So, first thing I want you to do is to just copy this down. We'll do two examples. Actually, no, I'll do three examples. I want you to just follow along with me, and then submit your answers, submit your notes rather on Canvas, and that'll count as a homework grade and a classwork grade. And you also have to finish the IXLs, which I haven't graded yet, so you have an extra day for that. I'm sorry, I wish I could get my webcam in here, but I feel like if I start it up again, it's just going to freeze my other camera. Anyways, go ahead and copy that down. If you're not copying down your problems on paper, you're going to have a real hard time doing them. I recommend doing that. It really helps us visualize things. It doesn't have to be beautiful or perfect. Of course, it's always nice if it is. Okay? All right, so there we go. So you might realize that this is a 60-degree angle. This is a special right triangle. Okay, if you remember, the first step we have to do is to just sketch the same triangle in the same orientation. Remember, this is a special reference triangle, so we have those side lengths memorized. Do you remember those side lengths? 1, root 3, and 2. Do this every time, and it'll become easier. So I'm just going to put a little squiggle around this thing. I'm going to call this our reference triangle, because that's what it is. Okay? So the first thing I would do is actually find this missing angle here, because that's probably the easiest thing to do. Okay, so all these angles have to add up to what? They have to add up to 180 degrees. That's the triangle sum theorem, which says that all angles sum to 180 in a triangle. Okay, so we know that 90 plus 60 plus some unknown, that was called measure of angle Q, because that's what it is equal to 180. Do a little subtraction here. We find the measure of angle Q to equal 30 degrees. So that's our first unknown, and that was the easiest one to find. All right, now let's get after these side lengths. You might find it easier to give this like a variable name. I'm not going to here, but feel free to do that if you'd like. You could call this X, and you could call this Y if you'd like. Might make your algebra a little more comfortable for you. I'm not actually going to do that just because they already have a name, and we should get used to using them since it's geometry class and all. So we should recognize that these are small legs, big legs, and hypotenuses. Remember that hypotenuse is always the side opposite the right angle. In this triangle, this is the small leg. In this triangle, this is the big leg. That's because this is a 30, 60, 90. If this was a 45, 45, 90, we would just have legs and a hypotenuse. And we'll see an example of that. So what I want to do is set up a ratio here. I'm just going to pick the ratio. I want to go after the small leg first for no good reason. Okay, remember you have to memorize this, or at least keep this handy to do this. So I'm going to pick a small leg to hypotenuse ratio because I know the hypotenuse. So I have to have a piece of the puzzle in my proportion in order to solve it. So I set up my proportion. This might look a little more familiar to you now. Might be coming back to you. Okay, I don't know what the small leg is. That's PR. The hypotenuse here is 6. So you don't have to, but I usually put my problem triangle in the first one. You don't have to though. And then in my reference triangle, the small leg is the 1, and the hypotenuse is 2. So now we just cross multiply. PR times 2 is 2 PR. 1 times 6 is 6. Divide both sides by 2. And PR is 3. Okay? So this is 3. Okay, so now we have to just do that process one more time to get this one more missing piece. And then it'll be a day for this problem anyway. So this time it's the big leg. After you get good at this, you can skip this whole process of picking a ratio. You can just go ahead and just do it. But I wouldn't do that until I'm pretty confident. I'll use the hypotenuse again just because that was what's given. If you base this off of this and you got this one wrong, then this will be wrong too. But if you base this off of this, what's given, then this will be right, even if that one's wrong. All right, so the big leg here is RQ, and the hypotenuse is 6. Again, I usually make my reference triangle the second one, my problem triangle the first one. So from here, the big leg is √3. Hypotenuse is 2. All right, we're just going to cross multiply here. We have 2 times RQ, and then we have 6 times √3.
What?
Divide both sides by 2, and we get 3 √3 for RQ. And then that's that problem.
I'm going to try logging off and coming back in and see if that works.
Okay, let's do another one.
What? Where?
Put these answers in here. 30 PR was 3, and QR was 3 √3.
Alright, just leave it there for now until I can get some pieces, okay? Pull it off. Can you believe that?
Okay, copy it down. Sorry, my daughter came downstairs. Our dog has a tick somehow, which is crazy because it's winter.
Mama, when I couldn't get off the bed, she like quit. It was biting already, like hard.
Okay. Hi guys, sorry.
It's okay.
So, I opened up that checkpoint.
Yeah, just copy this down.
So that you
All right,
can
on a
always
piece
go
of
back
paper.
in and look at the
As I'm doing it as well.
And the multiple choice, the review multiple choice.
All right, so you'll notice that this is
all of these
also
are just open
special
optional
reference
extra
triangle,
practice
and I cannot give them decimal answers, so trigonometry is not going to help me here. So I have to, oh, this thing froze again. Why this always does that, I'll never know.
I can change that.
Okay, so
You want like 5?
special reference triangle, right? So we know we're going to have to use a reference triangle.
Here, I just put it in.
So I also know pretty quickly that must be 30 degrees, right? It must be 30 degrees because it's 30, 60, 90. So go ahead and sketch your reference triangle off to the side. Try your best to make it, in the same orientation, the same proportions. All right, and if you remember correctly, your small side is 1, the hypotenuse is 2, and then I fill in this one √3. If you're ever not sure, you can always do the Pythagorean theorem and make sure that it's true, and of course it is true, right? So we set it up right.
Hey guys, I just want you to know that I
All right, so let's go after that small leg first. Remember, this is the small leg. This is the big leg. This is the hypotenuse. Hypotenuse is always opposite 90 degrees. The small leg is always opposite the smallest angle, and the big leg is always opposite the medium angle. So let's take the ratio of small leg to hypotenuse. All right, in this problem, the small leg is unknown, right? GI. The hypotenuse is 2 root 41. In my reference triangle, this is the reference triangle, the one that you have to sort of remember. Small leg here is 1. That's why I do it in the same orientation, right? And the hypotenuse here is 2. Let's go ahead and cross multiply. So I have 2 times GI, and I have 2 root 41. Divide both sides by 2. And GI is root 41. Okay, let's go ahead and do the big leg. Again, I'll use the hypotenuse to complete my ratio. So in that problem triangle, the big leg is HI. The hypotenuse is 2 root 41. Okay, the reference triangle, the big leg is root 3. And the hypotenuse is 2. Cross multiply. Oop, what am I doing? And then here I have 2 times root 41 times root 3. Now that might give you guys a little bit of a hard time at first, but if I have square roots, they just multiply each other. I'm going to divide both sides by 2. Sorry, I'm getting a little bit out of kilter here. These 2's cancel, and I have 41 times 3, so that's going to be 120, 123, so square root of 123. And I'm pretty sure that that's prime. Well, it's not prime because it's divisible by 3, but it's not going to be able to be reduced. Right? 41's not divisible by 3, is it? I don't think. Let's find out. Let's throw it into the answer and find out. So HI is root 123. GI is root 41, and H is 30. 30. Okay. One more of these. Remember, once you get past these special reference triangles, you can get onto the trigonometry ones, which I think actually might be a little quicker. And we have plenty of examples of doing those, so there's no real need for me to go over that. All right. Go ahead, sketch it out. And remember, like once you get good at this, you don't have to do all those little steps. It's not going to take you as long as it takes me to do it because you don't have to explain it on the way, you know? All right. So 45, 45, 90. It's actually a pretty easy one because, again, you can use the triangle sum theorem and remember, or figure out, rather, that this must also be 45 degrees. Okay, remember that angles are proportional to their opposite sides, right? Like, oops, hit my head there. The bigger the angle between my hands, the bigger the space between my fingertips, right? So that's that direct relationship between angles and opposite sides of a triangle. Smaller the angle, the smaller the space between my fingertips. Like imagine that's like, you know, draw a line here. That's the other side of my triangle, right? And if I widen that, then I get a wider angle and I get a wider side. Basically, this is how it works. So if I have 2 congruent angles, I have to have 2 congruent sides. So if I find this one, I find that one automatically. Go ahead and sketch your reference triangle. Okay, if you should remember this, but if you don't, 1, 1, root 2. And if you forget, just do the Pythagorean theorem, and you'll see you end up with a true statement. All right, these are legs. This is, of course, the hypotenuse. All right, so we'll do a leg to hypotenuse ratio. There literally isn't much else I can do other than hypotenuse leg, right? I usually like putting my unknown up top. So I actually forgot to get the Q, R, and P. Okay, so QR up top. The hypotenuse is 3 root 2. Okay, in my reference triangle, right? This is my reference triangle. You have to memorize that one. The leg is 1. The hypotenuse is root 2. So cross multiply them. Right? Now to get QR by itself, I divide by root 2. And that works out nicely. No rationalizing involved. So QR is just 3. And if this is 3, then this must be 3. All right, so there's that problem. 3, 3, and 45. All right, guys, so turn those in. Get this IXL done, the 3 that I had assigned, R8, R9, R10. I'll address any emails you have. The gradebook should be updated. I'll make sure it's updated with anything you've mentioned, any problems that you might have known. Take these notes that we have here, turn them in, just so I know that you've watched the video, and get that IXL done. All right, that's all I have. So how do I stop this thing?